So is my screen visible to all of you?
Yes, ma'am.
Is the screen visible?
Yes, ma'am.
Okay. So last time we talked about the importance of spiral model and how it flows from the shortcomings of the waterfall model. So this diagram basically shows and describes how a spiral model looks like and functions. So see, these are all the iterations of the software development, and at each iteration you can see that there is a step of risk analysis involved, and at the same time the prototypes are getting created in every iteration. However, what is happening in each iteration is quite different. So in the first one, maybe you develop a concept of operation and then plan a life cycle. In the second one, you take steps like requirement validation and development plan. This RQT is basically a software development framework only. And then in third iteration, you go forward backing on from the previous one, but at the same time, at each iteration, you are doing the risk analysis. So risk analysis and prototype is the main thing you should watch out for in the spiral model, and it is called spiral because of the nature of its functioning. So we will take an example of how risk assessment is actually done in a spiral model. So this table shows a risk assessment template. So ideally, at any stage in spiral model, if you're trying to assess the risk, you would be creating this template and filling in the details. So the first element in the template, in the risk assessment template, is the objective. So you need to explain what is the goal of the software project. So, for example, in this particular case, your intention is to improve the software quality of the existing software quality. However, there are certain constraints. So, software development usually comes with lots of constraints. You have to prioritize and rank those constraints, and that again depends on how well informed you are about the nature of your project and what you expect out of the outcome of the project and who is it going to serve. So all these details are very important, and this is not to say that software developers have to do all this, but because software development is a larger team in which project managers are there, business analysts are there, designers are there, so these are some collective tasks that are done. So the constraints could be that you have to improve the software quality within a period of 3 years. So that's a time constraint. The other constraint is without large scale capital investment and without radical change to company standards. So the idea of having constraints is that, obviously the resources are limited, time is limited, and still we have to achieve our product development. So that is why we need to know the limited context or the constraints that have been imposed in the development that we have to abide by. Because otherwise there would be a lot of flux of all these resources which an organization or a team may not be able to afford. So that is why when you're assessing the risk, you have to know the constraints also. Now, knowing the constraints and the objectives, so what are the alternatives you have got given the constraints? So, to improve the software quality, given the constraints, you could either reuse the existing certified software or introduce formal specification and verification for the softwares that you have created that is currently in use, or you may invest in testing and validation tools. Now, so these are the alternatives or these are the solutions to improve the software quality. You could reuse the existing certified software, so you may not use the existing software that you have been using because you want to significantly improve the quality, so you go down to certification certified softwares, or you introduce formal specifications and verifications in your own software, or you invest in testing and validation tools. So there are certain risks associated with it. So given you know what you want to do, you have the constraints and you have the solutions. Now, the important aspect in spiral model is you need to understand the potential risks for this phase. So, here you might like to write it down like this, that no cost effective quality improvement is possible, or for this particular case, quality improvements may increase cost excessively. So, obviously, when you're talking about improving software quality, it comes with increased costs. And as the software quality is improved, maybe it might lead to, erosion of existing staff because they may not be required. So that is also a risk, because sometimes you may want that staff for some job, but in between if it snaps, then it will be very difficult. So, understanding the risk and the nature of risk obviously depends from the objective of the project. So, if your objective is considerably different in the three projects that have been given to you, so obviously the nature of risk will be very different in each phase. Having identified the risks, having identified the constraints, objectives, and the alternatives, now you come to the solution stage. You try to resolve the risks that you have identified. Now, studying the existing solutions through literature survey could be one way to resolve the risks that you have experienced in this process. You could develop a small project, pilot it, and then see whether or not it resolves the risk. Or you could survey the potential reusable components. So these details are not as much important because they are obviously specific to the context. But the idea that you must get from this table is, you need to also identify the way you will resolve the risks at a particular stage if you are following the spiral model. Now, then you have to anticipate the results also, because based on the anticipation of the results, you will expect whether or not you should go or not go. So, in this particular example, what the team had done was they had tried to introduce training in the formal methods. So, they were trying to train their staff to, improve the formal specification and verification. But what they found out was it was causing a lot of overhead for them. So as they found out that experience of formal methods was limited in the staff, so it was very hard to quantify the improvements, and limited tool support available for company standard development system. So these were the limitations that they were facing, and as a result of which the result that they were expecting was not up to the mark. So what they finally decided was that they would explore the software reuse option in more detail, and explore also the certification schemes, because ultimately the other alternatives were not working. So essentially they identified this first one, they would reuse the existing software, certified software. And then in the later stage, they decided to fund a further 18-month study phase. So more important than the details in this example is your understanding of how you would go through all these different elements in the template when you are assessing the risk. So that is what we mean by risk assessment in spiral model. If the risk is too high and the throughput or the output that you are getting is somewhat not convincing both in an intuitive manner or in a rational manner, then you might need to, stop the development at that point and go and think of how you can improve the things, and then again come back and design your system. So that is why this was one of the difference between the waterfall model and the spiral model, which introduced sort of a an ethos of developing prototypes, and at each prototypical level you were assessing the risk of whether we should move ahead or we should stop, reflect, or move back. So this is how spiral model was conceived. So this was about spiral model. At this juncture, I want to ask a question, because from waterfall model, we have understood the gaps in the waterfall model, and then we talked about spiral model. But do you think something could be done in the waterfall model itself to improve it? rather than creating a drastically new model or proposing a new model. Obviously, there are many software development lifecycle models, but once you know the shortcomings in the waterfall model, what do you think could have been done in a better manner in waterfall model itself uh, to to make it a better method for software development lifecycle? Is the question clear? So you know about the waterfall model, you know about a bit about spiral model. Now I'm asking you to go back to waterfall model, and if you were to sort of introduce some new changes in the waterfall model to make it more effective, what could you think of? Okay, so you could increase your interaction with stakeholders. So Sandeep, when you talk about feedback systems, so which feedback would flow from where to where? Which entities would participate in feedback system? How do you imagine the feedback system going on? So I would want more details on that. And then Prasad says if we can stimulate consequences of changes somehow, we can drastically improve waterfall model. Okay, so it's basically creating a simulated version of what is expected. And then when we are fully confident, then we can go ahead. Okay, so that is sort of a testing in simulated environment. Garvit says that we could repeat the particular phase of waterfall model until unless we are done with that phase. But on what basis would you repeat the particular phase? What do you mean exactly by repeating the particular phase? Unless and until you're confident that you are done with that phase. So whenever we compare that we are done, there is always a comparator. So uh, on what particular risk and client satisfaction, yeah, or whether or not the software is actually doing what it is expected to do at that particular stage. Uh, from the feedback system, Sandeep, you mentioned that user to developer feedback is important. Definitely, but in waterfall model, the product is not fully developed until at the last stage. So think of feedback in terms of much earlier in the model. How would feedback play if you have to introduce it somewhere in the earlier phase of the model? How would it look like? So even in a particular software development lifecycle model, instead of full project, we can just present a prototype to the user. Yes. So again, when you talk about creation of a prototype in a waterfall model, it has to go through the process of requirement analysis, system design, integration, unit testing, and all that stuff. And by that time, a prototype is there. But we are asking if if you were going down the steps in the waterfall model, if there was a process that you could communicate with the previous stage, given the current stage you are in, you have finished everything, and then you go back to the previous stage and verify whether or not what was expected has been percolating down the waterfall model. So this is the basis behind, yeah, we could allow amendments to SRS occasionally, obviously based on some logic and rationale. So, when we talk about developments or improvements in the waterfall model, there's something called as iterative waterfall model that comes up. So, in iterative waterfall model, you are not just going through one iteration of the waterfall model, but you are doing it back and forth for every stage. So, again, what was the need for iterative waterfall model? So, it sort of attempted to um, improve the what was the missing gap or the loophole in the waterfall model. I would say it attempted because again it did not fully was able to accomplish it, and that is the result that other models came up. And so instead of introducing feedback at a much later stage, it sort of envisioned introducing feedback at an earlier stage. Now, uh, when we talk about feedback at an earlier stage, we do not necessarily are talking about feedback based on the prototype that has been created. Feedback would also be based on, for example, you did functional and non-functional requirements of the software and I will be reviewing them. So on that also I will be giving you feedback. So feedback at every step so that by the time you are at the implementation stage, you have done a lot of feedback and homework back and forth. But this should be an exception rather than the rule. Because again, the philosophy of waterfall model is that it just goes in one direction. There is very little room to go back. So, waterfall model was a rigid approach with linear rules having little room for flexibility. Iterative waterfall model created some space for flexibility. I would say some space because it is still a waterfall model. So that is what it attempted to do. So iterative waterfall model looks something like this. So you do requirement analysis, then you go to design, you design, and then once you have designed, you again go back to the requirement analysis to just to verify whether it has been done properly or not. And then you stage by stage go. So what is happening here is that you are again, when you are at a particular stage, if you find something really not working properly, then you go back to the previous stage. It is not a mandate. So, but this should be an exception rather than a rule. So you don't always go back because and you must have solid reason to go back to the previous stage because when it comes to large scale projects, going back could be very costly. So iterative model essentially gave created this room in waterfall model that at a later stage, when you find out that there's a need for extra work in an earlier stage, you go back to that earlier stage, try to rectify it, and then percolate down the usual traditional waterfall model. So this was what iterative waterfall model attempted to do. But again, it cannot be said that it correctly rectified or fully rectified the traditional waterfall model because essential fact about waterfall model is that waterfall should flow downwards with little possibility of going back. So, but then at this point, when we talk about going back to an earlier stage, it is important to assess and estimate the costs associated with repeated iterations to an earlier stage in the software development. So while finding error is important, while testing is important at every stage, but in the previous graph we had seen in the last class that there are costs, there are market costs associated with it. So, what do you think would be the other costs associated with if you were to repeatedly iterate to an earlier stage in the software development? What does it basically mean if you have to continuously go back to the previous stage in the software development when you are working on the current stage? Or what does it reflect? What do repeated iterations to the previous stage reflect if you have to do it again and again? What do you think? So in the iterated waterfall model, you are making iterations to the previous stage based on if you find something lacking in the current stage. And if you were to find out that this is happening continuously, what would it reflect and why it is not advisable? Okay, yeah. So the strategy, it definitely would cast a question on the quality of the strategy that has been formulated. Yes. That means the thinking has not been very profound in the previous stages and has been done in a quite hasty manner, which is reflecting poorly in the next stage and the repeated iterations. So the idea of prefixing the word iterative to waterfall is to create a space for if something goes wrong, not to make it readily available. because ideally it is still a waterfall model, but with some room of flexibility and adaptability should things go wrong in the some current stage that a developer might be working on. So at this stage, it is important to ask within your own teams also that you know about waterfall model, you know about spiral model, you know about iterative waterfall model, and we will be discussing our V model also and agile models also. So it is time to start discussing among your teams which kind of model you will be following. But it's not that there is only one specific type of model you can follow. There is something called as hybrid models also. So you can borrow things from different models, and depending on how suitable they are for the problem that you're working in, and given you're able to verify theoretically and conceptually that why you have introduced a particular strategy in your software development life cycle, then it should not be a problem. So think through about all these things. As you have pointed out, that going back and reworking on the tasks we had completed reflects poorly on planning the software development process, not to mention it is quite taxing. And yes, when it comes to software development, there are almost always deadlines there. So if you are doing too much of iterations, then it could really mess up with the project completion dates. And what happens is that because of this, by the time you come at the testing stage and you have developed your software, uh, your team would become so anxious in delivering the software that you may not be able to spend time on testing that you would otherwise have done. So normally it is seen that when projects are running quite late because of the repeated identification of mistakes and bugs, what happens is that testing really takes a backseat, and then it comes back to bite when it is raised in form of voice of customers or testers. So this is one thing we should always keep in mind. So obviously, now that we know that making mistakes can be costly, however, it is also controversial that what is the cost of fixing mistakes later in the stage. And I will also shared a paper with you. So do go through that paper. So the idea is that even if when I'm speaking, you should not readily believe it in a face value. You should always try to question or try to perceive the other side of what has not been spoken and reason to arrive at a fuller understanding of things. So now that we know there are certain costs associated with mistakes at a later stage, how do we prevent it? So it's a natural question that arises that how can we minimize the mistakes at software development in later stage? First of all, it is feasibility study. Whenever we are trying to develop a new solution, we have to study whether or not it is really required, how useful it is, how feasible it is to implement. Because in the long run, it will definitely save us lots of resources and time. So there are basically in feasible study, there are three key questions you need to ask. Is there a new and better way to do the job that will benefit the user? So assuming that you already have some way in front of you, then you have to really critically envisage and examine whether there are new and better way to do the job, what are the costs and benefits of the alternatives, and what is recommended. So what we are essentially trying to do when we are asking these questions is we are trying to identify the trade-off between investing the energy in developing the software and the anticipated outcome or the expected outcome of it. We can only estimate that, and so that alone may give us a red flag or green flag, but it may not be always clear. But however, if you're solving a problem that really means something and you do a feasibility study, then it should provide you sort of logic to proceed. And feasibility study is not only native to software development. I think for big projects, be in education, health, or even politics. Feasibility study is usually carried out because the idea is that once you obtain green flag from the feasibility study, then you can be more confident of investing resources into that project. So that is why, if otherwise, if something emerges in the feasibility study, then you can rectify it or use that red flag to sort of prevent making some huge mistakes at a later stage. So feasibility study generally would summarize what is known on the subject and what is going to be done. So basically, it consists of statement of problem, summary of findings and recommendations at the very initial stage. So this would involve talking to people who are involved, stakeholders, the people who are directly affected. And so basically, it involves lots of interviewing and ethnographic studies also in some manner. Then you detail the findings, and based on that, you find out recommendations and conclusions. And based on that, then you know whether or not you should proceed with the project or not. So this itself takes a lot of time. In the projects that you have been given, you may not be required to do feasibility study, because they have already been given to you and in a much more boxed manner. But later on in your life, when you will be taking a project or maybe starting your own company or creating your own solution, then definitely you would be expected to do the feasibility study of the idea or the project. So, again, so that we minimize the errors in the next stages, it is extremely vital that whichever stage we are at, we put our full heart and soul into that stage, so that we are arriving at an objective identification of what is required to be done in that stage. So first stage is obviously the requirement analysis and definition. So in this stage, you must analyze requirements for whom. So who are your primary consumers, the secondary consumers, who are directly and indirectly impacted by the product that you are creating. So you need to talk to these people. You need to consult the system users, clients, stakeholders to establish the system services, basically a better knowledge about what services are expected, the constraints related to those services, and the final goal. So in the projects that you are doing, so you have your team members, and I put myself as a primary stakeholder and client. So you would ideally want to discuss the questions and the confusions that are arising in assessing the requirements, in identification of requirements. And then through our dialogue, you will be able to arrive at a better understanding of these requirements. Then you can later define them in detail after having a preliminary understanding. So, more details about this stage, so that the errors in this stage do not percolate down to the design stage, because the stages are linear, especially in waterfall model. It is quite likely that any loophole in the previous stage would not only percolate to the next stage but would also magnify, because it is in the next stage of the development. So that would again cost you a lot. So that is why, once you understand the requirements, you understand them from all the people who are associated with the project, you analyze them. Analysis is important because obviously you cannot fulfill all the requirements. It's it's logically impossible to fulfill all the requirements, because we have constraints of time, resources, and even technology. So that after having jot down the requirements, you need to analyze those requirements with your team members and obviously with your stakeholders also, because you don't want to operate in a universe in which you are fulfilling the requirements which are suitable according to you but may not be suitable according to the clients. Then it would definitely defeat the purpose. So requirement gathering, requirement acquisition, and requirement analysis is very important, because it will provide you a firm understanding of what is to be done in the next phase, which is system and software design. So in system design, you basically partition the requirements into hardware or software. Although it is important to remember that there is no standard division of requirements. In the last lab, we saw that requirements could be partitioned into user requirements, system requirements, or functional requirements, non-functional requirements, hardware and software. So again, There are no set rules. It basically boils down to the context of the product you are developing. Whatever suits to the context in which you are operating, your team members are operating, and whatever makes the most logical sense to what you are trying to accomplish, you should follow that approach. In this stage, you would technically design the overall system architecture which we would explore in much more detail in next week about all the kind of structured designs and the entity relationship diagrams and UML design. So we will be talking about all these. And in this stage, you identify and describe the fundamental software abstractions and their relationships. So how different elements, how different classes are interacting with each other to ensure the flow of the information is proper, because here you are not coding, you are just putting down the DNA of your software, the blueprint of your software. Based on this blueprint, you will be working to actually implement it through code. So it is very important you get this stage clear. This stage will be clear only if your previous stage is clear, because they are very much interdependent on each other. That is why once you are done with this design, do not jump back to next stage immediately. Try to spend time on the software architecture you have designed. Discuss it among your team members. Sleep over it. Try to understand how information is moving through this entire architecture, and try to see it from the consumer point of view, from the end user point of view. Because when we think of the design that we have made from the end user point of view, what happens is that we keep that side of ours a bit away, which is looking for convenience. So, according to my convenience, I will design the architecture like this. But developers' convenience might not be actually what the consumer has expected. So that is why you need to really brainstorm over this particular design, because after you take off from here, you will be implementing and there should be very less possibility of going back because of the costs involved. So after system design and after having discussed and spent considerable amount of time over it, and your team members are confident that now we can, you know, literally throw ourselves in implementation stage, then you start writing set of programs and program units, and then you also keep on testing the individual units to verify that each unit is meeting its specification. So after you have done this unit testing and preliminary implementation, then you sort of try to integrate the different program units you have formed and then provide a system-wide testing. So this is a very basic flow of how software development goes into picture. And I want you to also follow a systematic approach to software development, because then you can understand the structure of software development and how different units play together, come together to create something which may have some value to the customer. Last stage is operation and maintenance. So generally it would come as quite surprising that it is the longest life cycle phase. But when we develop a software, it is not always a standard software. The idea behind operating and maintenance is to standardize it, to an extent that most of the errors are resolved, and it becomes a framework in its own self. So maintenance involves correcting errors not discovered in the earliest stage of the life cycle, improving the implementation of program units, system units, and enhancing the overall system services as new requirements are discovered. So again, so this is not a software development is never a static process. It's always a dynamic process. Of course, in the 1980s and 1990s, it used to be seen as a static process, and the costs associated with that kind of vision was clear because of the much late time in which the softwares were coming up and the graveyard of software developed apps. So maintenance is extremely important. So even in your softwares that you are developing, try to keep considerable amount of time to test what you have created. And testing should not only be one time activity. You should be testing at each stage, and whenever your team member has developed something, some other team member can test it. So use the advantage of working in the team to increase the throughput of the product that you are making. Because slowly, this maintenance helps in bringing new systems to standards of the software that you have created. So these were the basic stages that I wanted to discuss, and these are discussed in the context of waterfall model, but they are overall applicable to all the software development lifecycle models at a much broader level. So at this point, I want you to look at this plot and how do you interpret it? What is it trying to show you? So is the plot visible?
Yes.
So how do you interpret this 2D plot? What information do you obtain from it? So so Sunny, so this is your
It
deduction.
is easy to fix an error if we find it early.
That is your deduction. That is your deduction from the plot. That is what you're interpreting from the plot. But from the plot, what is the observation? So we first talk about the observation from the plot, and then we extrapolate it to our interpretations or the conclusions that we are able to make. So you're saying that Prasad says the more we wait, the more costly it will be to recover or reconstruct. What? And Garvit says the later we find errors, the more costlier it will be to solve in terms of time and other resources. And what is the nature of this plot? So if you were to draw a line, if you were to use one term to explain this nature of plot, what mathematical function do you think would fit in here?
Exponential.
Exponential, yeah. So what does it mean? If you were to draw a straight line and then you have exponential, so the cost not only increase, it's not only costlier, it's exponentially more costly to be able to fix the errors in the later stage. So Prasad says that the more we delay testing, the harder it will be to fix errors of earlier phases. So here you see again the makers of this plot have shown that it's not so whenever the cost is quite less to fix if the error is detected right at the requirement architecture or at the coding and it considerably increases. So what would be your ideal plan knowing this plot? What would be your ideal approach uh, for testing if you want to minimize the cost associated with fixing the errors? Based on this plot, what would be your strategy? So, what would you do differently knowing this fact and knowing that you are creating a software or a prototype, knowing the fact presented in the plot, what would be your strategy or approach? So, before you text and fix errors in each phase of the development, again, this attitude has to prevail in the entire team about being very clear sighted about what we are doing and being criticizing in a healthy manner. So yes, to make an in-depth analysis of requirement and workflow required. So at each iteration of your software development. So obviously, suppose you have planned out your software development in the series of stages, and you are on a first stage. You discuss what is to be done. After laying out a plan, you ideally discuss with your team members before implementing. After implementing, then you go back to your specifications and then see whether the developed prototype is actually matching with the requirements that were specified in that particular stage, and then you test it. And even only after you are convinced, all of you, that it is good to go to the next stage, then you move on to the next stage. So it is not only about testing the prototype, but it is also about, so testing is a very general word. Let's say we would like to assess whether we are going in the right direction or not, examine or investigate whether we are going in the right direction or not. So obviously each epoch in the software development needs your testing eye, so that you don't repeat the mistake uh, which is too costly as it is shown in the figure. So it is not only about checking only in the times of coding or programming, but also in system design when you're designing the architecture or in the requirement analysis. So because I understand it is not very exciting thing to do, and so it might not readily come from us, but I can assure that it will definitely um play a very strong role in the overall success of the project. And by the overall success, I would mean it would definitely lessen the errors and mistakes you commit over the period of time. So yes, definitely look for errors, or not necessarily errors, but what is happening perfectly or what is not happening perfectly, and how we can improve what is happening. But again, because there is a time constraint, so there should be a healthy balance. Otherwise, as we had seen in the plot I had shown you last class, that the cost of testing may be much more than the market value. So, and this we learn through talent error. So doing the projects is a very good way to learn all these things. So let's imagine a scenario in which you are working on a large project. The system is quite complex. So this would, I mean, technically identify as a large scale project. So it is very natural to miss out on the details of the requirement phase. Again, depending on the scale of project, the requirements would differ, and it is uh, like practically impossible to anticipate all the requirements in the initial phase, especially when the system you are developing is complex. So the danger of this would be that we end up designing an entirely wrong product and provide it to the client, so it doesn't really serve its purpose. So to rectify this approach, another model was proposed, which is called as the V-shaped model. It's called V-shaped model because of the way in which it is approached. So essentially, it is a waterfall model, but it has been there have been certain changes that have been introduced in the waterfall model. So at each stage, so if when you're doing a feasibility study, you're reviewing the results of the feasible study, and once you do the review, you see the corrections, you again do the feasible study, then only you percolate down to the lower level of user requirement. Once you are at the user requirement stage, you sort of try to review the user requirements. So that could be by talking among your team members, or bringing certain sample of users into your project and trying to explain them that these are the user requirements you have formed and what they feel about it. You gather their feedback. Based on the feedback, you correct your user requirements, and then you go to system design. And similarly, in system design, once you have designed the system, hardware and software, and designed the architecture, then you sort of revisit it and do system testing both in the theoretically and conceptual manner, just to see that there's a logic in the flow of information, and whether or not all the user cases are satisfied, and if there is anything which is not being considered by the system. Once you are a bit confident about that, then you move to program design, and then you code, and then later on you can test also. So this is a sort of V-shaped model. So again, as I mentioned, The idea of discussing all these models is to provide you uh, further to think about what kind of model or what kind of hybrid model fits best in the approach that you are trying to solve. So basically, V model is an elaboration of waterfall model. It stresses the necessity of validation activities at each step in the waterfall model. It is very different from the iteration in the waterfall model. Can anybody explain what is the difference between iterative model and the V model, looking at the diagrams? So what is the main difference you see in the iterative waterfall model and the V model? After we discuss software development life cycles, I will launch a quiz also on everything that we have studied. Just and it will be marked also. So what do you think is the main difference between the iterative waterfall model and the V model? It's easy to get confused between the two. So if you notice from the diagrams, in iterative, you go back to the previous stage, but in V model, you are at that stage. You are validating what is happening in that stage, and then you get the green flag for that particular stage, and then you move down. So the feedback is not happening as much as the validation of that particular stage is happening in the V model. All right. So the only condition, however, for the feedback is that once you find that there is a discrepancy between the specifications in a particular stage and what was found in the next lower stage, so next succeeding stage, then only you go for the feedback mechanism in the V model. Otherwise, you always keep on validating or testing at a particular stage before fixing that or freezing that stage in time and then moving to the next stage. So basically, that is what V model attempts to do. So one of the examples could be that, for example, a system designer specifies a particular calculation to be carried out in a certain way. So the system designer has given the template of how a particular calculation should be carried out. Maybe he or she has written it in a document form. But the person who structured the software and who was expected to fulfill this design, he or she has misunderstood the requirements of the design specified by the system designer. But because the software has been made after the system designer specified and then the structure person who structured came into picture, and after the software was created, the system designer finds out when he or she is testing the software that there has been some problem in the way the document has been read by the program designer, as a result of which the software is not behaving in the expected manner. You see here the error has been misreading of the documentation or misreading of what was specified or expected to be done, and that has magnified its error and that has manifested in a very different form. This also is very important to consider when you are communicating among the different members in your team who are active in developing the software or aspects of it. It should be ideally, when you say A, it should be received as A. When you say apple, it should be received as apple. If there is a confusion between apples and oranges, then it can be very, very difficult going in the long term. So in this particular situation, after system designer identifies the error, ideally only correction should be fed back because the error is already clear. What is the error? So there was some misreading as a result of which some functions may have been misapplied. So only the correction should be fed back. You should not be spending too much time on what exactly is wrong because the system designer has already captured what has not been done correctly. So talking about the advantages of V model, they are suitable for restricted projects wherein you know what you are designing, where the technology is stable, The documentation and design specifications are clear. Therein V model can be used. Generally, they are used in medical device industry, wherein a particular medical device, it's known what it is expected to do and function. So there is not much change happening, and that is where V model can be used. It is also suited for projects that must maintain a strict deadline and meet key milestone deadlines throughout the project. But it may not be suitable for large scale projects in which continuously new versions and patches have to be developed. So that is one of the disadvantages of V model. And apart from that, it is not that adaptable. An overlooked issue within fundamental design discovered later can cause a lot of man hours and increased cost, as we saw using that plot. Then, although timeline restrictions are there, but the drawback of testing in the final stage, because in the V model, there is no testing happening. We are only validating the needs, but that is also sort of testing, but not the testing of the software. But nevertheless, definitely the errors in the software will be less if you have been validating each of the previous stages. But you should keep good amount of time for testing the software, because by the time software is finished, there is so much of haste in delivering the software or pushing it into production mode, that somehow you might be blind to some of the errors in it, might replicate and later come back to bite. So usually testing is done in much haste, so try to avoid that kind of error. And V model may not be suitable to lengthy life cycles, and it is not very much suitable to long-term projects, which may require many versions or constant updates. And because of this disadvantage, in the next class, we will be discussing our final software development life cycle, which is the agile methodology. And there is this question for you to ponder after the class. So there is a debate that V model tends to emphasize a development cycle that fits managers and users rather than developers and designers. So some people cite this as a disadvantage for V model. In the tomorrow's class, I will ask you, what do you think about it? So take this day to think more over this claim that has been made, that V model is more friendly to managers and users rather than developers and designers. And finally, so the conclusion is that development model selected for project depends on aims and goals of a project. So you should be very clear of what you are trying to achieve from your product, from your project. Based on that, you identify which model is the most suitable. It's possible that you might have to go for hybrid approach, depending on the reasons you identify as you work through various specifications of the model. And in any model, testing should be performed at all levels. By testing, it doesn't mean testing only the prototype, but validating what you are doing, being critical about what specifications you are specifying, so that in the long journey of the software development, the errors are minimized over the period of time. So, in today's class, I hope I was able to provide you a brief overview of how to do risk assessment in a spiral model, uh, iterative model, and how it is different from the waterfall model and what are the advantages, and again the V model of software development lifecycle. So at least I think you have enough initial knowledge to start making the decisions about what kind of software development lifecycle you will be following in your projects, and start documenting everything, every reason as to why you are doing all this. Basically, from requirements to system design to implementation and all these things, because documentation really helps us in retaining the information, and definitely help you to create better projects. So that is all from for today's class. And thank you so much for your patience. I know I've exceeded a bit of time today, but thank you so much.